The Labrador Sea is an arm of the North Atlantic Ocean, about twice the size of California. It lies between Canada and Greenland. Because it's so remote, you might not have spent a lot of time thinking about this body of water. But this remote sea plays a vital role in marine ecosystems. The Labrador Sea is also known as the ocean's lung. Thanks to a quirk of ocean currents, this sea is responsible for about half of the oxygen of all deep sea life in the Atlantic Ocean from the equator northward. And there's some evidence that the ocean's lung might be in a lot of trouble. The Labrador Sea brings oxygen to the deep through what's called density-driven circulation, or the movement of seawater based on its density. Although we often think of the entire ocean as being made of the same seawater, it's actually made of a lot of different parcels of water that might have different densities from each other. And just like oil and water, seawater tends to separate out into layers based on different densities. Less dense seawater naturally rises to the top, while denser seawater sinks to the bottom. Seawater density is dependent on two things: temperature and salinity. The warmer a parcel of water is, the less dense it is, and the saltier a parcel of water is, the greater its density. So cold, salty water tends to sink, but warm, less salty water rises. The Gulf Stream, which flows along the east coast of North America and into the Labrador Sea, is very salty. But because the Gulf Stream is also warm, its temperature keeps it just light enough to stay at the surface. When that warm water hits the frigid climate of the Labrador Sea, though, it starts to cool. And since cold, salty water is extremely dense, it sinks, moving all the way down into the bottom of the ocean. But remember, just before that moment, the water was at the surface in contact with the atmosphere. It's been absorbing gases from the atmosphere, including oxygen. That oxygen stays in the seawater as it sinks and gets brought down into the deep ocean. About 2 kilometers down, this seawater hits a mixing zone, which moves it south toward the equator. There, that oxygen is consumed by deep sea organisms. Because the oceans are all connected, it could even make it all the way to the Pacific and Indian Oceans. In fact, it's estimated that the Labrador Sea provides the oxygen for somewhere between half to 3/4 of all deep sea life in the North Atlantic, between the equator and 50 degrees north. And that's only for the oxygen. We've been able to trace half of all the total oxygen that passes through the Labrador Sea. Scientists are still working out what happens to the other half, but it probably also disperses throughout the ocean. We just haven't figured out its route or where it eventually ends up. So this area is clearly vital to a lot of marine life. But there's concern that climate change could affect how water, and thus how oxygen, moves through the Labrador Sea. That's because the Labrador Sea is right next to Greenland, and the Greenland ice sheet is melting. This is important because ice is almost always made up of fresh water. Under normal conditions, when seawater freezes, only fresh water becomes ice. The salts that were in the water stay dissolved in the seawater that remains. So when ice sheets form, the remaining seawater is always saltier because the same amount of salt is now dissolved in less water. And when they melt, the opposite happens. Fresh water comes back into the ocean, lowering the salinity. Now remember that salt is one component of density, which is the only reason why that Gulf Stream water sinks in the first place. If that water gets diluted, there's a chance that less of it will sink, which in turn will bring less oxygen to the deep sea. This same issue might be affecting more than just the Labrador Sea. Other areas in the world where density-driven circulation happens might also be affected by climate change, including other sources of deep-sea oxygen. And remember, carbon dioxide is also a gas, which means it enters the ocean in the same way as oxygen. Currents like the one in the Labrador Sea don't just bring oxygen to the deep ocean, they also take carbon dioxide from the atmosphere and hide it in the deep ocean where it can't easily escape. While this could be a big issue for deep-sea life, because carbon dioxide also acidifies seawater, currents like this one are one of the reasons why the ocean has been so good at absorbing the carbon dioxide we're putting into the atmosphere. So if systems like this weaken, the ocean could take up less carbon dioxide in the future, meaning global warming happens even faster. We still don't know the extent of these changes, but this could end up having severe consequences for marine life, on top of all of the other challenges the ocean is facing from other aspects of climate change. But it's important to remember that we can still change things. Taking action on climate change can stop a lot of its worst effects from coming to pass, and can give the ocean a chance to catch its breath.